So far we've talked about how to write vectors in component form, but we can also write it in a different form. The way we do that is we need to know some vector I, which is 1, 0, the component 1, 0, and some vector j, which is the component 0, 1. So essentially you'll see that I is in terms of x's and j is in terms of y's. So if we had some vector that was in component form AB, we could really write that the same as A0 and component 0b. So that's the same as A times component 1, 0 and B times component 0, 1, which is this form right here. And this has a special name, AI plus BJ. That's going to be called a linear combination, okay, of the vectors I and j. So if we look at example 5, it says let DE be some vector with initial point -2, 3 and terminal point 4, 5. Write DE as a linear combination of the vector I and j. So we need to first figure out our components of DE. So to figure out what DE is in component form, remember what did we do? We did A1, or we did X, this is X1, Y1, and this is X2, Y2. We took X2 minus X1, comma, Y2 minus Y1 in component form. And so I simplified and I'd see that I'd have 6, 2 in component form. So that's what DE is in component form. So now I want to write this in as a linear combination. So the way I do that is I look at my X component first, which is 6. Remember the I vector of component vector or standard unit vector was 1, 0. So this is actually going to be 6 times 1, 0. Then I looked at my Y component, which was 0, 1, and so that's going to be the same as 2j. So DE as a vector as a linear combination is going to be 6i plus 2j. And all I did is I took 6 from my component and 2 from my component and rewrote it out like this. Here are 2 examples. Feel free to stop the video and try these now. Now, let's say we have the components of some vector. Okay? We can actually use those components to find the magnitude and direction of our vector based on what we know about sine and cosine functions. So if we have some vector with components a, b, my x value, remember, was always my cosine. So that means that a is actually the same as the magnitude of b times the cosine of my angle. My y is the magnitude of my vector times the sine of my angle. And so we can rewrite it out as our linear combination like this. So let's look at an example where it says find the component form of the vector v with magnitude 10 and direction angle of 120. Well, we just saw that anytime you have some vector, its component form was always written as the magnitude of v times the cosine of my angle, and then the magnitude of v times the sine of my angle was the y component. So I know what my magnitude is, it's 10, and I know what my cosine or my angle is to find cosine and sine of it. It's 120 degrees. So all I have to do is just rewrite my component form as 10 cosine of 120 degrees and 10 sine of 120 degrees. And so I'll go into my calculator, put those in. I find my x component is -5. I put in 10 sine 120 in, and I'm going to get a decimal, but I get a positive 8.66. So that is the components of my vector that has a magnitude of 10 and a direction angle of 120. Here's 2 more examples. Stop the video now and go ahead and try these ones. Now let's say we know our components and we need to figure out our direction angle. Well, the way we do that is we use this equation right here. Okay? Tangent of theta is equal to the vector v times sine of theta over vector v cosine of theta. Sine over cosine, right? Well, remember this amount right here is actually just the component of b, and this right here is my component a. So all I have to do is just b over a is equal to my tangent of theta. So if I'm looking at question A here in example 7, tangent of theta is going to be equal to b over a. So in a linear combination, it's always ai plus bj, right? So my b in this one is going to be 7, and a is going to be 3. So really this is saying tangent of theta is 7 over 3. Now, if I know tangent of theta is 7 over 3, how do I find just theta? I do the inverse tangent of both sides, and inverse, and I go to my calculator. My tangent inverse says it is 66.8 degrees. Okay? Now, in letter B, they give us it in component form, which is helpful because, again, tangent of theta is just going to be b over a, negative 5 over 4. I take the tangent inverse of both sides, and I find that my theta is approximately negative 51.3. Now, we never had a negative angle for our direction angle. So what I'm going to do is I'm actually going to say, okay, so if it's in a negative 51.3 degree rotation, that's the same as 360 plus that negative 51.3. And so it actually ends up being 308.7 degrees. Because I only want positive angles, I don't want negative. And so you'll see right here, when we have component 3, 7, we get, this is actually wrong, it's supposed to be 66.8 degrees. And then right here, same thing. Okay, component 4, negative 5, it's down in the 4th quadrant. My rotation is 308.7 degrees. Okay, here's a couple guided practice problems you can try on your own as well. So, let's put all of this together to create a word problem. It says a quarterback running forward at 5 meters per second throws a football with a velocity of 25 meters per second at an angle of 40 degrees with a horizontal. What is the resulting speed and direction of the pass? Alright, so let's put this all together. So what I'm going to do is first I'm going to find the first vector in component form. And that's going to be this one with the quarterback is running. Okay? So, we know that our magnitude is 5. Cosine of, well, if it's straight, that's going to be 0 degrees. And 5 sine of 0 degrees. And so I find that my first vector is actually going to be just the component 5, 0. I did that by doing that on my calculator. Now let's find the second vector. Okay? Now this one is magnitude of 25 meters per second. Cosine of, and it's 40 degrees. And we also have 25 sine of 40 degrees. Okay? I put all of that into my calculator, and I find this to be 19.2, 16.1. Okay? So now I have my two vectors. And we learned that if we're going to find our resulting vector, we're just going to have to add these. So I'm going to take my first vector 1, and I'm going to take my vector 2, and I'm simply going to add them together. So my resulting vector, okay, R, we'll call it, is just going to be V1 plus V2. So that is 5, 0 plus 19.2 and 16.1. So my final resulting vector, R, is going to be, well, 5 plus 19.2 is going to be 24.2. And 0 plus 16.1 is just going to be 16.1. So that's my resulting vector. Okay, I can use that information now to figure out both the magnitude and the direction. Okay, so remember, my magnitude is going to be, magnitude r was just a squared plus b squared, right, in component form. So for us, it's going to be 24.2 squared and 16.1 squared. Okay, I put all that into my calculator, and it comes out to approximately 29.1 meters per second. Okay, so that's how fast the football is traveling. Now we have to figure out. So he threw at a 40-degree angle, but was running forward at a 0-degree angle. So we just found out that tangent of theta is equal to b over a from our component form. So b is 16.1 and a is 24.2. So I take the inverse tangent of both sides, and I find that my theta ends up being about 33.6 degrees. So to answer my question in its entirety, the football is traveling with a magnitude of 29.1 meters per second in a direction of 33.6 degrees. And I'm done. Here's one more thing we could think about. It said, what would be the resulting velocity of the football if the quarterback was running at 5 meters per second backwards with the same speed? So my hint for you would be my first vector would actually be -5, 0, because he's running backwards. And my second would be the same. And you could go from here.